What if the universe itself is not still, but in motion, forever stretching, as though reality were breathing outward into the unknown? For most of human history, the cosmos was imagined as fixed, eternal, a celestial dome under which stars traced their unchanging paths. Galileo, with his fragile telescope of glass and brass, shattered that illusion. He revealed a sky alive with detail, moons circling Jupiter, mountains etched upon the face of the moon. Yet even then, the greater universe seemed unmoving, an infinite stage with no beginning and no end. Centuries later, Albert Einstein unveiled the mathematics of general relativity, a language that reshaped gravity into the curvature of space and time. Within its equations lay a hidden truth. The universe could not remain static. It must either expand or contract, shifting under the weight of its own geometry. The thought disturbed him, seeking to preserve the comforting vision of a timeless cosmos. Einstein introduced a delicate balance, the cosmological constant, a mathematical tether to hold the universe in place. But the sky had other plans. In the 1920s, Edwin Hubble, peering through the giant eye of the Mount Wilson Observatory, measured the faint light of distant galaxies. Their glow was stretched, shifted toward red as though space itself were pulling them away. One by one, galaxies revealed their secret. They were fleeing in every direction, carried upon an expanding fabric of reality. In that moment, the universe ceased to be eternal and unchanging. It became dynamic, restless, and young, a cosmic story unfolding. With a beginning written in fire and a future still unwritten, the revelation arrived not with thunder, but with silence. A faint shift in the color of starlight. A whisper of galaxies receding, their light stretched thin by unseen hands. It was a discovery that would rupture the oldest human assumptions. For generations, philosophers and astronomers had believed the universe was eternal. Aristotle spoke of celestial spheres that had no beginning and no end. Even Isaac Newton, who defined the laws of motion and gravity, envisioned an infinite cosmos held steady by a perfect balance. The stars, they thought, would shine forever, suspended in an endless, unchanging frame. But the observations of Edwin Hubble shattered that ancient vision. Each galaxy was not fixed, but fleeing, and not in one direction, like sparks from a fire, but in every direction at once. The further they were, the faster they receded. The geometry of the cosmos itself was expanding. The implications were staggering. If the fabric of space was stretching today, it must have been smaller yesterday, smaller still the day before. Push the clock back far enough, and everything we see, every star, every planet, every atom, collapses to a single point of origin. A moment when space and time themselves were born. The birth of the cosmos. The Big Bang. This idea struck like lightning through the scientific world. It suggested that the universe had a beginning, a finite moment in the past when everything emerged from unimaginable density and heat. To some, it felt less like science and more like myth reborn. For how could existence itself have a first breath? Einstein himself had resisted this conclusion. His equations, free of the cosmological constant he once introduced, naturally predicted expansion. But he had doubted such a universe could be real. Later, confronted with the evidence, he called the constant his greatest blunder. The cosmos was not balanced. It was alive, restless, and changing. Yet acceptance did not come easily. The notion of a beginning unsettled many. A static universe felt safe, eternal, a steady stage upon which life could play out. A universe that began suggested it could also end, but all things, even time itself, were impermanent. The shock ran deeper still. Expansion in everyday life requires a medium, a background into which things move. A balloon swells into air. A ripple spreads across the surface of water. A cloud of smoke disperses into the atmosphere. Intuition demanded that the universe, too, must be expanding into something larger. A void, a container, an outside. But cosmology defied intuition. Scientists explained that space was not expanding into anything. Space itself was stretching. Galaxies were not flying apart through emptiness. Rather, the emptiness itself was growing, carrying galaxies along like leaves upon an ever-widening river. There was no external arena, no greater space into which our cosmos expanded. Space and time were self-contained. The universe was not in something, it was everything. For many, this realization was harder to accept than the Big Bang itself. Human thought is built upon comparisons to the familiar. Yet, the cosmos was not like anything on Earth. It was not a fireball exploding into the sky. It was a swelling of reality itself. In the decades that followed, astronomers sought proof. The theory predicted a faint afterglow, the cooling echo of that primordial fire. In 1965, Arno Penzias and Robert Wilson discovered it by accident. A soft microwave hiss, uniform across the sky, left over from the Big Bang itself. The static on their radio antenna was not interference, but the remnant heat of creation. It was confirmation beyond doubt. The universe had a beginning. The expansion was real. The shockwave rippled beyond science into philosophy, theology even, art. Humanity was forced to reimagine its place in time, no longer in an eternal stage, but in a story, with a past, a present, a future yet to be written. Still, questions multiplied. If the universe was expanding, how fast? Would it expand forever, thinning into eternal cold? Or would gravity one day pull it back, collapsing in a final fire, a mirror image of its birth? These became the obsessions of 20th century cosmology. But beneath the calculations lay a deeper unease. Expansion without an outside was a notion that strained the mind. What did it mean for reality to grow without a beyond? Could the human brain evolve for survival on a small planet ever truly grasp it? The scientific shock of the expanding universe was not merely in the data, but in the way it forced humanity to abandon its intuition. To think not in terms of familiar metaphors, but in abstractions alien to daily life. To accept that the universe was not a place within something else. It was all there is, growing not into space, but of space. The galaxies, once thought eternal and fixed, revealed as waypoints in a vast journey outward. And with every measurement of redshift, every observation of faint light from the deep past, the same unsettling truth resounded. The universe is not what it seems. In the silence of the night sky, continued to swell, indifferent to our confusion. The stars drifted further apart, carried upon a tide without shore, into a mystery deeper than imagination. The sky holds memories older than the oldest stone on earth, buried in the darkness between the stars. There is a whisper, not of starlight, but of something far more ancient. The faint glow of a beginning in 1965, two young radio astronomers at Bell Labs, Arno Penzias and Robert Wilson, stumbled upon a mystery that would change cosmology forever. Their great horn-shaped antenna had been built to capture signals from satellites orbiting Earth, but it delivered something unexpected. A persistent background noise. No matter where they pointed it, day or night, season after season, the static remained. They thought it might be interference, perhaps from the city nearby, or even from pigeons nesting in the antenna. But after every careful test and every meticulous cleaning, the signal endured. It was not noise. It was the afterglow of creation itself. The faint, cooled radiation left behind when the first atoms formed and light was freed to travel. A fossil of the Big Bang. Echoing across the whole of the sky, this was the cosmic microwave background, the very first light the universe ever released. Its existence was predicted by theorists decades earlier, but no one expected to stumble upon it so suddenly. Here was proof that the universe had once been hot and dense. That expansion was real. Decades later, satellites would carry humanity's gaze further, mapping this ancient afterglow with unprecedented clarity. The COBE mission in 1992 revealed the first full picture of this primordial light, a pattern mottled and uneven like a cosmic fingerprint. Those tiny ripples in temperature, mere fractions of a degree, were the seeds of all structure. From them, galaxies, stars, and planets would grow. Then came WMAP in the early 2000s, refining the map with breathtaking precision. The universe was shown not as a smooth fireball, but as a tapestry of quantum fluctuations stretched across the infant cosmos. Finally, the Planck satellite, launched by the European Space Agency in 2009, delivered the sharpest vision of all. A portrait of the universe when it was only 380,000 years old, an infant, still glowing from its birth. Each mission told the same story. The cosmos was expanding. It's not just stars flying outward, but space-time itself stretching. Oh, the cosmic microwave. Background carried the record of that moment, etched into its very fabric. Yet with these discoveries, a new question emerged. How fast is the universe expanding? Astronomers called it the Hubble constant, in honor of the man who first revealed the flight of galaxies. At first, estimates varied wildly. Some believed the cosmos to be only a few billion years old, others far older. It was a debate that spanned generations, because measuring the expansion rate meant measuring the scale of reality itself. Gradually, scientists improved. Kipid variable stars, pulsating like cosmic lighthouses, offered a way to judge distance. Type Ia supernova detonations of dying stars became markers across the abyss. Satellites tracked the faint signals of galaxies, while ground-based telescopes reached deeper into the night. Bit by bit, the expansion rate came into sharper focus. But then, in 1998, came the revelation that shook cosmology to its core. Teams observing distant supernova expected to see evidence of a universe slowing down. Its expansion gradually tamed by gravity. Instead, the explosions revealed the opposite. The cosmos was not decelerating. It was accelerating. Galaxies were not just drifting apart, they were being carried faster and faster into the dark. This discovery was more than unexpected. It was terrifying. It implied that some hidden force was at work, a pressure woven into the vacuum of space itself. Scientists called it dark energy, but the name was little more than a placeholder for ignorance. No one knew its nature. It's only that it existed, and that it dominated the universe. Nearly 70% of all that is, bound up in a form we cannot touch or see. That shock of acceleration deepened the mystery of expansion. The universe was not just growing, it was racing away into nothing, as though driven by an invisible wind that no equation could yet tame. Einstein's cosmological constant, once abandoned, returned to the forefront. Could this mysterious acceleration be explained by the same mathematical term he once introduced, then discarded? Or was it something new, a dynamic field that shifted over time, reshaping the fate of the cosmos? The data only sharpened the paradox. The more astronomers measured, the clearer it became. The universe was not expanding into anything at all. It was creating its own stage as it went, stretching not into space, but of space. And the acceleration meant that vast regions would drift, forever beyond reach, carried faster than light beyond the cosmic horizon. Galaxies once visible would vanish, their light stretched into invisibility by the very fabric of reality. The evidence, rather than resolving the puzzle, carved it deeper. How could a universe born in fire not only expand, but accelerate, without anything beyond to push into? How could emptiness itself possess energy, a force greater than all stars combined? Astronomers pressed forward, using ever more sensitive instruments. The Hubble Space Telescope measured distant galaxies with clarity unmatched from Earth. The Planck data confirmed the overall shape and content of the universe with exquisite precision. 5% matter, we know, 25% dark matter, 70% dark energy. The cosmos revealed itself as both mapped and mysterious. Its essence quantified yet unfathomable, and still the central riddle remained. Expansion without an outside, acceleration without a cause we can see. The universe, it seemed, was not only larger than we imagined, it was stranger than we could believe. The galaxies continue their silent flight, their redshift deepening with every passing second. Behind them, the afterglow of the Big Bang still glows, a reminder that we are children of a beginning, watching as the story grows more intricate with every page. But the pages do not turn into anything beyond. They write themselves into the void, and the void becomes reality. The deeper the investigation, the more profound the unease. The universe expands into nothing, and yet it is everything. It accelerates, pulled by a force unnamed, and in the silence between the stars, it leaves humanity with a question that is both scientific and philosophical. How can everything grow when there's nothing beyond it? The revelation of acceleration tore open a wound in our understanding of the cosmos. What was once thought to be the simple outward motion of galaxies became something stranger, deeper, and more haunting. A new actor entered the stage of science. Unseen yet all-powerful, it was given a name that hinted at ignorance more than knowledge: dark energy. This mysterious force, or property, appeared not as matter, not as radiation, but as something woven into the vacuum itself. It could not be touched, could not be held. Yet it revealed its presence in the grandest gesture imaginable by commanding the fate of the universe. It drove galaxies apart, stretching space-time faster with every passing moment. In its grip, the cosmos was not merely expanding, but accelerating. Here the paradox sharpened. Expansion without an outside had already strained human imagination. But now, acceleration insisted that the universe was not just moving outward into some hidden void, it was unfolding within itself. Space was not carried outward into a larger arena. Rather, the very coordinates of existence were swelling, redefining distance and time. Philosophy wrestled with this vision. In ordinary experience, growth requires a boundary, a medium, a backdrop. A tree grows into air. A flame spreads into surrounding darkness. A balloon inflates into the room beyond it. But cosmology tells another story. The universe does not grow into anything at all. Its expansion is not into, but of. The analogy of the balloon is often offered to soften the blow. Imagine its surface as two-dimensional space. As the balloon inflates, the surface expands. Galaxies like dots on the skin drift farther apart, though none are moving across the surface itself. Even this image misleads, for a balloon expands into the air of a room, into dimensions we can touch. The universe has no such luxury. Its outside exists only in mathematics, not in the physics of our experience. What then does it mean to expand without beyond? To swell into nothing, and yet become everything? This is the haunting question that deepens the mystery. The human mind recoils at the thought. Intuition insists there must be an edge, a frontier, a place where the universe ends and something else begins. But when asked, cosmology replies with silence. The edge is not physical, it is temporal. The horizon of the universe is simply the limit of what can be seen, not the end of what is. Beyond it, the fabric continues, unreachable, unobservable, carried too swiftly by expansion for light to ever return. There is horror in this realization, and awe as well. Every star, every galaxy, every atom is caught in the slow unspooling of existence. Space itself is the tide, and all matter is adrift upon it. The Earth orbits the Sun circles the center of the Milky Way, and the galaxy itself is swept outward, like a raft upon an infinite ocean that no shore contains. Reality itself is stretching, and with it, all that it carries. Acceleration magnifies this fate. With every passing billion years, more galaxies slip beyond the horizon, their light stretched until it vanishes. A future awaits where only the closest companions of our galaxy will remain visible. Beyond them, darkness. A universe where the wider cosmos becomes unknowable, not because it does not exist, because expansion itself has hidden it forever. And yet the deepest question remains unresolved. If expansion is of space itself, does it have an ultimate limit? Is there an edge, not in distance but in meaning? If the universe is finite, like the surface of the balloon, then it curves back upon itself, without boundary. Travel far enough, and one might return to the starting point. But if it is infinite, then it has no edge at all. It stretches endlessly, without ever reaching a frontier. Here lies the most haunting paradox of all. The universe may be boundless, yet still expanding. Infinity itself may be swelling, growing larger without ever needing something outside it. This vision defies the imagination. How can infinity become larger? And yet in the mathematics of cosmology it can. The equations of general relativity permit it, and the observations demand it. Dark energy sharpens this paradox further. Its nature is unknown, but its consequences are clear. If it remains constant, the cosmos will accelerate forever stars, drifting into silence as expansion tears the night apart. If it grows stronger, the acceleration may one day rip even galaxies, stars and atoms themselves, ending all structure in a final disintegration known as the Big Rip. If it weakens, gravity may yet slow its hand. Though evidence today suggests otherwise, each possibility is unsettling, each one reshaping the question of what it means for the universe to expand into nothing. For in every scenario, the outside remains absent. The cosmos is the totality of existence, with no beyond to contain it, and so humanity is left staring into a sky that is both familiar and alien. The stars shine with ancient light, yet the fabric beneath them is not still. It is restless, alive, growing not into emptiness, but of emptiness. The balloon analogy falters, the metaphors collapse, and only the stark poetry of mathematics remains to hold the mystery. In that, mathematics lies both beauty and terror. For it says the universe is not what common sense declares. It is not a thing inside a larger container, not an object with an edge. It is self-creating, self-defining, and infinite in ways the mind cannot embrace. Its growth is not measured against anything else. It's the measure. The escalation of discovery has left humanity humbled. What began with a faint shift in starlight has become a riddle that pierces the very heart of reality. Expansion without an outside, acceleration without cause. A universe that grows into nothing, and yet consumes everything. The horror lies in its indifference. The all lies in its scope. The deepest question lingers, unanswered. If the universe has no outside, then what does it mean to say it expands? If it has no edge, then what lies beyond? Perhaps nothing, perhaps everything. Perhaps words themselves fracture at the boundary, leaving only silence. The riddle of expansion does not end with discovery. It deepens, demanding explanations that stretch not only the fabric of physics, but the fabric of imagination. At its root lies Einstein's general theory of relativity. In 1915, it declared that space and time are not a stage upon which events unfold, but a fabric woven by mass and energy. Gravity is not an invisible pull. It is the bending of this fabric itself. In this vision, expansion is not a movement into something else, but the swelling of the fabric itself. Space-time stretches, carrying galaxies apart as though they were painted upon an inflating canvas. The question of into what dissolves, replaced by the idea that the universe is its own container, its own definition. But relativity only framed the mystery. It did not explain why expansion began, nor why it accelerates today. For answers, physicists turn to the earliest moments of the cosmos, fraction of a second after its birth. In the 1980s, Alan Guth and others proposed the theory of inflation, a moment when the infant universe expanded faster than light, not in violation of relativity, but within its permissions. Space-time itself, unrestricted by the cosmic speed limit, ballooned in a trillionth of a second, smoothing the universe and setting the stage for galaxies to form. Inflation explained puzzles long unsolved. Why is the universe so uniform across vast distances, when light had no time to travel and mix its properties? Why is space so nearly flat, balanced delicately between collapse and runaway growth? Inflation offered answers, a rapid, explosive stretching that ironed the cosmos smooth, yet inflation carried a startling consequence. In many versions of the theory, it never ends. While inflation stopped in our observable region, creating the bubble we call the universe, it may continue elsewhere, spawning new bubbles endlessly. Each could expand into its own cosmos, with its own laws of physics, forever hidden beyond the horizon. This eternal inflation births the idea of the multiverse, a sea of universes, each swelling into a larger cosmic foam. If such a vision is true, then our universe is not alone. Its expansion is not unique. It is one bubble among countless others, each swelling within a grander framework we cannot see. In that case, the outside is not meaningless. It is the ultimate frontier, though forever sealed from observation. Science rooted in data cannot yet confirm this. The multiverse lingers at the boundary, half theory, half speculation, yet hauntingly plausible. Closer to home, another idea takes root in the strange world of quantum physics. Even in perfect vacuum, space is not empty. It seethes with quantum fields, where particles flicker in and out of existence. This vacuum has energy, subtle, pervasive, inescapable. Could this vacuum energy be the dark energy that drives cosmic acceleration? If so, the expansion of the universe is written into the very definition of emptiness. Space does not expand into nothing. It expands because of nothing, because emptiness itself is unstable, infused with energy that presses outward. Yet the mathematics betrays us. Calculations of vacuum energy overshoot observations by numbers so vast they defy belief. 10120. Times greater than reality. No physical problem in science has ever seen such a gulf between prediction and fact. The cosmological constant problem remains unsolved, a scar upon the union of quantum theory and relativity, and within this quantum vision lies an even darker speculation: false vacuum decay. What if the universe is not in its lowest energy state, but a temporary plateau? So, the vacuum could collapse, falling into a truer state. A bubble of new physics would form and expand at the speed of light, rewriting the laws of nature as it consumed the old. In such a fate, galaxies, stars, even atoms would vanish, replaced by rules alien to anything we know. Expansion, then, would not be only growth, but transformation into an entirely new reality. This chilling idea is not mere fantasy. Some interpretations of the Higgs field discovered at CERN in 2012 suggest that our cosmos may indeed be metastable. The timescale could be billions of years, or it could be sooner. The uncertainty adds a layer of fragility to existence itself. Expansion may not only stretch the cosmos, it may one day erase it beyond quantum fields. Another framework emerges: string theory. In this vision, the fundamental particles of nature are not points, but tiny vibrating strings. Their vibrations give rise to forces in matter, weaving the universe at its smallest scales. But string theory demands more than the 3 dimensions of space, and one of time we perceive. It suggests additional hidden dimensions, curled tightly beyond our senses. Could these unseen dimensions be the stage upon which expansion unfolds? Perhaps the universe does expand into something after all, not into nothing, but into realms our perception cannot access. If space-time is part of a higher dimensional structure, then expansion may be the unfolding of that structure itself. The balloon analogy, once limited, acquires new depth. The balloon's surface is our universe, but its volume invisible to us is the higher dimensional reality in which it swells. In such a picture, the outside is both real and unreachable. It exists, but not for us, string theory offers. Elegance, unifying gravity and quantum mechanics in a single framework, yet it remains untested, a vision awaiting evidence. Still, its suggestion is profound, that the true theater of expansion may lie beyond perception, in dimensions we cannot touch. Each theory reshapes the question. Relativity tells us expansion is intrinsic. Inflation declares it was born in a flash. The multiverse imagines endless bubbles swelling together. Quantum fields whisper that emptiness itself drives the growth. False vacuum decay warns that expansion may transform reality into something new. And string theory opens the possibility of hidden dimensions, where the stage of expansion is far larger than the world we see, but none dissolve the paradox completely. Each stands as a fragment, circling a truth too vast for final capture. Is the outside meaningless, a word that fails before the cosmos? Or is it the ultimate frontier, a place beyond place, forever hidden yet hauntingly real? In this uncertainty lies both fear and wonder. Expansion continues, heedless of theory, Galaxies recede, their light stretched thin. The universe grows not into, but of. And in that growth, humanity is forced to stretch thought itself beyond intuition, beyond metaphor, into realms where imagination alone may glimpse what reality has yet to reveal. Theories and speculations are more than explanations. They are mirrors reflecting the limits of human reason and the hunger to surpass them. They are reminders that the cosmos is not simple, not comforting, but vast, strange, and humbling. Expansion without outside remains the paradox at its heart, the riddle around which all science and philosophy orbit, forever reaching, never arriving. To confront the mystery of expansion, humanity built instruments that reach far beyond the limits of the eye. Metal and glass, sensors and mirrors, they became the extensions of curiosity, the prosthetics of wonder. For the universe to reveal itself demands more than vision. It demands patience, precision, and the courage to ask questions that may never be fully answered. The Hubble Space Telescope, launched in 1990, became one of the most transformative of these tools, suspended above the blur of Earth's atmosphere. Its mirror captured starlight undistorted, opening a window of unprecedented clarity. It measured the faint flicker of Cepheid variable stars and the dying flare of Type Ia supernova, refining the expansion rate of the cosmos. With each observation, galaxies emerged not as eternal beacons, but as milestones along a cosmic journey outward. Hubble's deep fields revealed galaxies billions of years old, frozen snapshots of the universe when it was young and restless. Their red-shifted light was not merely distance. It was history, stretched by the expansion of time itself, yet Hubble was only the beginning. In December 2021, the James Webb Space Telescope unfolded its golden mirror in the cold silence beyond the moon's orbit. Larger, more sensitive, it peers deeper still, into the first galaxies, into the afterglow of creation itself. It does not just see farther, it sees earlier. Its infrared gaze pierces the veil of dust, revealing the hidden architecture of the early cosmos. Each faint glimmer it detects carries the imprint of expansion, the signature of a universe that has been stretching since its birth. While telescopes probe the vast, other tools dive into the small. Particle colliders, like the Large Hadron Collider beneath the soil of Geneva, smash protons together at energies unimaginable in nature today. Their collisions recreate moments reminiscent of the infant universe, when temperatures and densities were extreme. In these flashes, physicists probe the Higgs field, the quantum vacuum, and the possibility that dark energy may be rooted in the fabric of nothing itself. Though the collider cannot reproduce cosmic expansion, it whispers of the forces that underlie it, hinting at why the vacuum has energy and whether it could one day shift. Meanwhile, new space missions rise with singular purpose. The European Space Agency's Euclid telescope, launched in 2023, now maps the dark universe, tracing the distribution of galaxies across 10 billion years of cosmic history. Its measurements will refine the fingerprints of dark energy, testing whether it has remained constant or evolved over time. Soon NASA's Nancy Grace Roman Space Telescope will join the search, scanning the skies with a field of view 200 times greater than Hubble's. Its surveys designed to chart the subtle distortions of light caused by dark matter and dark energy alike. On Earth, the Dark Energy Spectroscopic Instrument, DESI, opens its 5,000 robotic eyes each night to capture the spectra of galaxies across a third of the sky. From those spectra come redshifts, delicate measurements of how far each galaxy has traveled on the river of expansion. Together, they create a three-dimensional map of the cosmos, a chart of the universe's growth carved from millions of galaxies. It is cartography not of land or sea, but of existence itself. Even with these instruments, the mystery deepens. Every refined measurement of the Hubble constant, the expansion rate, sharpens attention. Nearby galaxies suggest one speed, while the distant afterglow of the cosmic microwave background suggests another. This Hubble tension gnaws at cosmology. Is it a flaw in data, or a hint of physics beyond what we know? Perhaps dark energy is not constant. Perhaps the early universe obeyed laws we have yet to grasp. Every new observation may not resolve the puzzle, but open new doors into strangeness. Alongside telescopes and colliders, computers have become silent laboratories of creation, cosmological simulations running on the most powerful supercomputers. Evolve billions of particles and dark matter halos across billions of years. They test the growth of structure under different assumptions of dark energy. In the luminous patterns of galaxies within these digital universes, scientists compare prediction with observation, seeking clues to whether our cosmos behaves as expected or whether its expansion hints at something more radical. These simulations are not mere numbers. They are experimental universes, conjured in silicon, where humanity rehearses the mysteries of reality itself, and still, new hopes rise on the horizon. Gravitational wave observatories, sensitive to the tremors of space-time itself, may one day detect the faint echoes of inflation ripples born in the first instance of creation. If such signals are found, they could confirm whether the universe ballooned faster than light in its infancy, and whether our bubble may have brushed against others in a cosmic multiverse. 8. The fabric of reality may yet tell its story through vibrations in silence, carrying secrets no light can reveal. Despite these monumental efforts, science remains far from an answer. Each tool refines the mystery rather than dissolves it. The universe still expands without outside. Its acceleration still defies comprehension. Dark energy remains invisible. Vacuum energy remains mismatched. Inflation remains unproven. The multiverse remains speculative. Progress comes not as finality, but as deeper glimpses into an enigma that seems designed to retreat as we approach. And yet, there is beauty in this pursuit. For the act of searching itself reveals the human spirit. Telescopes pointed skyward, the colliders buried underground, the satellites that circle above, simulations humming in quiet rooms, all are extensions of the same question. What does it mean to live in a universe that grows into nothing? The answers may never be final. The expansion may remain forever beyond comprehension, a riddle written in mathematics too vast for human minds. But through science, the riddle becomes visible, and in its visibility, humanity finds meaning, not in conquering the unknown, but in walking alongside it. The tools are not weapons against mystery, they're lanterns. Their light does not end the darkness, reveals how deep the darkness truly is. What does it mean to live in a universe that expands, but not into anything? The question lingers like an echo in the mind, unsettling, impossible to hold. Every instinct demands an answer, yet the answer refuses, slipping away into paradox. 4. Expansion, as human experience knows it, always requires a beyond. A balloon swells into air. A flame spreads into darkness. A ripple spreads outward into water. But the universe is different. Its expansion is not into, it is of. Time and space themselves are growing, not moving into some hidden arena, but weaving the arena as they go. The outside never was. There is no stage on which the cosmos is placed, no larger void into which it pushes. The universe is the totality of reality, and what lies beyond it is not absence, but non-existence. This is the final humility. The realization that human thought itself falters before the immensity of cosmic geometry. Minds evolve not to grapple with infinities, but to gather food, to find shelter, to survive on a fragile planet. Brains trained to sense distance, weight, motion, things measured on scales of meters and seconds, not parsecs and eons. It is no wonder that the shape of the cosmos feels incomprehensible. It is not that the universe is strange. It is that the mind is small. Perhaps the very question, what is it expanding into, is flawed, a reflection of intuition misplaced. Like asking what lies north of the North Pole, or what does time look like when there is no before. Questions collapse under their own weight, dissolving not the mystery, but the limits of the language used to approach it. The universe may not fit into the categories human thought has built, may require new categories altogether, and yet there is wonder in this limitation. For in failing to comprehend, one glimpses the scale of what is being asked. To stare at the stars and feel confusion is to feel the proper proportion of humanity's place within the whole. Not at the center, not masters of the story, but participants, small, fleeting, and yet conscious of the infinite. Science presses forward, its tools sharpened, its theories refined. But the horizon of knowledge recedes with every step. The universe is not revealed as simple, nor comforting. It is revealed as vast, elusive, and humbling. Each discovery multiplies the questions. Each answer opens a deeper riddle. Expansion without outside, acceleration without cause. Cosmos both infinite and finite in ways the mind cannot reconcile. In this, there is a quiet beauty. For the mystery itself is the gift. The universe does not yield its secrets easily, but it allows glimpses enough to inspire, awe enough to remind that existence is not ordinary. To live is to live inside the only known universe, a cosmos still becoming, still stretching, still writing itself into being. The stars drift further apart, silent witnesses of this expansion. One by one, galaxies beyond our own will fade, there, light stretched beyond visibility, slipping past the cosmic horizon. A day will come when only the closest galaxies remain, and then only silence. The night sky emptied not by absence, but by the very growth of reality itself. The horizon recedes into unreachable distance, a boundary not of walls but of speed. Beyond it lies a universe forever hidden, not because it is not there, but because expansion has sealed it away. What remains for humanity is reflection too. Ask not only how the cosmos grows, but what it means to live in such a cosmos. If the universe is not within something, but is everything, then existence itself is the boundary. Beyond it lies no space, no time, no outside, only nothing. And even that word is too heavy, for it suggests something that can be imagined. The truth may be stranger still, not nothingness, but the absence of even that. And yet in the silence of this realization there is comfort. To exist within everything is to be part of a whole without edges. Every star, every planet, every fleeting thought is woven into the same expansion. The universe does not happen around life. Life happens inside the universe, inseparable from its unfolding. Perhaps then the question is not into what does the universe expand, but what does it mean that it expands at all? It means that existence is dynamic, restless, alive. That the cosmos is not a static monument, but a journey. Time itself is not a backdrop, but a river, carrying all things into futures. Yet unseen, in the end, the mystery remains. Expansion without beyond, acceleration without cause, horizons that hide more than they reveal. But in that mystery lies the essence of wonder. For if everything were known, there would be no awe. If the cosmos were simple, it would not deserve the silence it inspires. The stars drift, the galaxies fade, the horizon recedes. Still the universe grows. Not into something, but of something, weaving space and time with every heartbeat. Of existence, humanity watches, questions, imagines, and in doing so, takes part in the most extraordinary story of all, the story of a universe that is not within anything, but is everything.